Very good morning, everyone. Uh, Guys, we'll wait for a couple more minutes. Only four members joined. Okay, and then we'll start the class. Okay. Okay, guys, let's start the class. Okay, let me open the account and share the screen. Okay, linear regression. So in the linear regression, multiple regression, we will see. We have already discussed the theoretical part of the linear regression. Today, what we will do is we will do some uh, practical of these things. Okay, so it's all these are not necessary. Okay, done. So what we will be doing is like we will take a data set called as Boston data set. Okay, so what does the Boston data set will do is it will give you mm, uh, it will give you the different perspective of a particular person. Okay, whether what is the PET ratio. Okay, and what is his age, what is the tax amount of tax paying, and some other parameters. Okay, so based on these parameters we need to figure it out whether the house information we need to find it out. So let's we do one thing. Okay, so we go to this particular github profile, we'll go to this. So all these are the data sets. Okay. Hmm. Okay, see. So here we have got some sort of information about the data set. Let me share you that. Okay. So here the Boston data set, this consists of very small data points, which are 489 basically records we are having. And this particular data set mainly targets for the median value of the owner occupied homes. Okay, so here the feature, sorry, here the feature RM, which gives us the average number of rooms, okay, per square feet or per dwelling, we call it as. Okay, per, or you can consider as the average number of rooms in a particular house. okay, in that particular area or in that particular region. Okay, L stat, okay, is nothing but the percentage of population considered low status. Okay, L stat, low status. Okay, what is the percentage? See here, uh, here we are having the L stat. So 4.98 is the percentage of the population considered as a lower status. Okay, so this particular each record is considered to be an considered to be an like entire Boston regions. Like Telangana or in Andhra Pradesh, we'll be having some districts, right? Okay, in the same way, the Boston has been divided into some regions, and over that regions, this is the data point. Okay, medv, nothing but the median value, okay, or the value, some value of or average value of how many homes are occupied by owner, how many homes, okay, are occupied by owner. Okay, see, for this particular region, 24% of the homes are occupied by the 24 homes were occupied by the owner, and the rest of the homes were being rented. Okay, rest will be rented. Okay, so most of the homes are being rented. Okay, the owners are buying the homes and they are giving the rents and they are enjoying the the income getting from that home. Okay, so here what the problem statement you need to understand is, so based on these ratios or based on these features, you need to predict whether if in a new town is got added into the Boston, okay, or somewhere you want to apply these kind of principles in some other country or some other district or some other state. Okay, so how you will be analyzing the data, okay, how you will be preparing the data. Okay, that's a problem statement here. Here our target value is medv, nothing but the median value of the owners occupied the homes. Based on these values, if the new data comes, it will predict the medv. Okay, based on these values, it will give you the it will give the value, like it will predict uh, how many, what is the percentage of it, what is the median value or what is the average value of it, you can calculate it. Okay, so there's a problem statement here, what we are having here. Okay, so whatever the problem statement it is, the only thing is that first you need to identify the target variable. Identify the target variable. Identify the target variable. That's the first thing, guys. Okay, what is the target variable? This is the target variable. Okay, we have identified, and these are the independent variables. Sorry, these are the independent variables. Okay, we have identified. Okay, identify the target and independent variables. We have done that. Okay, that's the thing. Next what we have, next we need to check the distributions and everything we need to do, which is called as EDA, exploratory data analysis. Okay, so whatever the outliers you are checking, and whatever the uh, null values you are getting, okay, and whatever the pre-processing part you are doing, so all these will distributions you are finding out, all these things will come under the EDA. The third one we have discussed is the Pre-processing. Processing nothing but the cleaning of the data. Okay, like removing, finding out the outliers comes under the EDA. Removing the outliers comes under the pre-processing data. Standardizing the data comes under the pre-processing data. Okay, so all those concepts will come. And next, split the data into test and train. Okay, we will split this 489 data points. Okay, 489 data points into say for example 70-30%. On 70% we will train the model and 30% we will test it. What is the accuracy? Okay, that's what we do. Fit the model on train data and validate it on test data for the accuracy. Okay, next, measure the performance. Measure the performance. Okay, so whatever the problem statement you do, so it has to follow these 6 steps. These 6 steps it has to follow. Whatever the problem statement it is, whatever it is, whatever the problem statement it is, no matter what it is. Okay, either it may be the housing prediction or some price prediction or some any algorithm or any problem statement. You need to remember these 6 statements. Okay, for you follow the steps one by one. Okay, so before that, what we will do, we will just import the pandas. Okay, pandas got imported. And here what we are doing, we are reading the CSV file. CSV file is present in this particular link. I will post this particular one in the text box. Okay, you, if you want, you can download that one, or you can simply use this URL to load it into the pandas data. Okay, you run it. Okay, what I'm doing here, I'm verifying the first 5 rows. Okay, using the head function. We have already discussed this. Okay, it will give you the first 5 rows. So here I am using the info. What does the info will give us? That how many null values are there? How many not null values are there? What is the data type of each row you are having? So all those things will present in this info. Okay. So if you run this, see this, what is the size? What is the size? It's a 506 size. Okay, nothing but the rows, how many records you are having, it's 506 records you are having in the data set, what data set we have took. And how many columns you are having 14 columns. You are having 14 columns. Okay, and how many not null counts are there? 506 not null, all these are the, okay, you are not having any kind of null values. And then what you are doing the D type. You are checking the D type. Okay, so this is a data type. D type is nothing but the data type. So CRIM is the CRIM is the float data type. Okay, chars is the int data type. So all are the numerical data types. So directly you can apply the algorithm on top of this. Okay, that's the thing. Next, you are having the describe data set. Sorry, describe function. So it will give you the summary statistics on each column. Summary statistics. We have seen this form. We have seen this function. Okay. So what did it give us? The first one, the count how many non null values are present. What is the mean value here? 3 point something. Okay. What is the standard deviation here? 8. Okay. What is the minimum value and what is the maximum value and what is the percentile? 25th percentile, 50th percentile, and 70th, 75th percentile. Okay. So that percentile values we will be getting. One second. Okay. That's the thing. And next, for all the columns, it will give you. Okay. So if you see here, for some thing, the mean value is in 3 digits, and for some of it is 400 digits and everything. Okay. So you can standardize this particular one. Okay. But it's not necessary to standardize for the logistic, sorry, linear regression. Okay. So the reason behind is that it is a pure mathematical formulation. So you can ignore that standardization for the linear regression. Okay. Directly you can apply whatever the thing you want. Okay. So see here. So these are the columns. These are the columns. Okay. So y is the target variable. So y is equal to, I am using that particular column. I'm fetching that particular column and I'm storing in the y variable. So house of midway means I will get only this y column. Okay. I am taking this y column and I am storing that y column in the y variable. Okay. And the rest of the columns I'm using it in the x variable. Okay. I'm dropping the midway. Okay. I'm dropping the midway. Okay. And whatever the rest of the columns are having, okay, independent variables, I'm keeping it in the x-axis. Okay, be careful, guys. This is the same process you will be doing. Whatever the variable you have identified as the target variable, that particular target variable, okay, that one particular target variable, you will be keeping it in a y variable, in some separate variable, and the rest of the independent variables, okay, columns, those things you'll be keeping it as a x. Okay, keeping it in the x. Okay, so we are using this particular sklearn package. Okay, sklearn package is a kind of like machine learning algorithms package. It will have all the functions required for developing a model. Okay, it will have all the functions. No matter what it is, it will have all the functions. Okay. So here I want to split the data into train and the test. Okay. Train, train data and the test data. Okay. So what I am doing here, I am just passing the x and y, whatever the things I have done here, both I am just passing to the train test split. Okay. What should be the size of the train size? 70% I am using. If you want to use the 80% for training, you can take. Okay. If you want the 60%, you can take, or if you want to go with the 50-50, you can take. Okay. But 70% is the ideal one for test train split. Okay. And the random state, you can give any value here, guys. You can give one, you can give zero, or you can give some 1, 2, 3, 4. You can give some random numbers, anything you can give. Okay, so what does this random state, what it will do is, see, every time whenever this particular function runs a train test split. Okay, So what it will do is, from the X and Y, it shuffles the rows. It shuffles the rows and it will pick the random 70% of the data. Okay, it will shuffle the rows especially. Okay, so if you don't use this random state, see for example, I'm not using this random state. Let me run the above one. Okay, I'm not using the random state here. Okay, if you see the X underscore train, so it's capital X, right? See, you are getting this data, right? 0.387. Okay, if I run the same process again, see, I will copy it. I will run the same process. See, if you compare to, you have run this again, this particular test train split. Okay, so in the second run you have got different value here. See, here you have got 8 0.387152, some record you have got, the record number is 287. The record number is 2 the record number is 287. Okay, but if you see here, the record number is 25. Means every time it will shuffle and it will give you the new set of data. Okay, every time it will give you, and it will return the new set of data. Okay, that's why we need to use a random state. You can give any value, some constant value you can give. It should not change basically. Okay, it should not change. Say for example, you have given random value 22. Run it. Okay, run it, and just now use this just train. Okay, you have got the 301 row in the first. Again you run this, again you will get the same data. Okay, again you will get the same type of data. So for that purpose, for every time you run, if you want to get the same set of data, then you need to use the random state, give any some constant value. If you don't use the random state, every time you run, you will get the different data set and it will work differently and you will get a different accuracy. Okay, sometimes you will get the high accuracy, sometimes low accuracy, sometimes it will fluctuate. Okay, so that's the reason we need to give the random state. I hope this point is clear why we are using the random state. Yes, guys, yes or no? Guys, you following? Jyoti, Narasimha, Swati. Jyotika, Kumaresh, you there? Mhm. What is the axis one? Okay. So when we understood about the pandas, where it is here, right? So when we learned about the pandas, we have seen the axis, right? Okay, axis zero represents, if axis equal to zero, okay, this represents row. Okay, if axis is equal to one, column. Okay, here you are dropping the column. Means here you are dropping the column. That's the meaning of the axis equal to one. Okay, so you can also write column as well. Like this also you can write. Okay, but instead of typing that much, we can simply give the axis as one. That's it. If you want to drop a row, you can use the zero. Okay, if you want to drop column, you need to use one. That's the thing. Okay, let me clear all these. Okay, now what I am doing in the scikit-learn, from scikit-learn dot linear model. Okay, we are having a class called as linear regression. Okay, a function called as linear regression. Okay, so there is no need of applying all the entire formula what we have learned yesterday. Okay, so this will do the work for us. Okay, all that formula applying, and you will get to whatever the beta b0 b1 b2 b3 values, whatever they are. Okay, all those values we will get without any sort of hard work. Okay, without any sort of hard work, just use it like this. Okay, and then what you are doing, you are creating a class of it. I mean, you are creating an object of it, model you are creating. Okay, so here we are having the x train and the y train, right? Okay, x train and y train you will have. Okay, so that x train and y train, you are fitting that one into this particular model using the model dot fit. In the model dot fit, you are giving the x train comma y train. Okay, it will fit that particular model. It will fit that particular model. Okay, model has been fit. Once the model is been fit, what you will be getting, you will be getting the values here. Say for example, mm, okay, y is equal to, yesterday we have seen b0 plus b1 x1 plus b2 x2 plus b3 x3 plus b4 x4 plus b5 x5, like this, b6 x6. Okay, and so on. How many x variables are there? Here we are having all these are x. Okay, so this represents y is nothing but medv is equal to B0 plus B1 into CRIM. Okay, X1 is nothing but CRIM plus B3 into INDUS, Indus. Okay, sorry, B2, right? B2 plus B3 into CHAS. This one. Next, we are having NX plus B4 into NX. Same way, like that, you keep on adding all the things till this L stat. Till this L stat. All these things you will get. That formula will be applied. Okay. And then you will be getting this B0, B1, B2, B3, B4. All these values will get calculated. Okay. These values. And you will also get B0. B0 is nothing but the intercept. Y intercept. Okay, so if you want to find out what is the y-intercept, model dot intercept underscore, it will give you the y-intercept. Model dot coefficients, nothing but b1, b2, b3, b4, like that. You'll be having all those coefficients, right? The slopes in the hyperplane. Okay, those values you will be getting. Those values you will get like this. Everyone on the same page till this point? Yes, guys. Jyotika, clear. What about the others? Nandini, okay. 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 Next. Next, we have split the data into two parts, right? 70% for the training. So we fit the model on the training. Now it's time to test the accuracy. Okay. Now it's time to test the accuracy. So how you will be testing the accuracy here? We have split the data into X train and X test. Okay. X test. So on this X test testing data, we will predict the model. So Y test is the actual data. Okay, so for this particular data set, this is the actual Y test is the actual output. Okay, what we will do, we will do the testing on this particular X test. Model will predict something. Based on that something data, we will, with the help of this Y test, we will calculate the performance. Okay, that's a very simple. Now see. Okay, so we are doing the prediction on the test data, X test. Okay, so let's do the prediction here. Prediction is done, and you will get the data like this. Okay, we have got the data. Now we have learned the mean absolute error, mean absolute percentage error, mean square error. Okay, all these things we have learned. Okay, so directly you can import that one from metrics of sklearn package. Okay, there is no need of again installing the sklearn if you are using the Anaconda environment. Already all the built-in packages you will be having. Okay, sklearn will also have like that only. So from sklearn.metrics, from sklearn.metrics, Okay, you are importing mean absolute error, mean absolute percentage error, and mean square error. You have many such kind of things here. Okay, you just need to import it. Now, what you need to pass, what is the y test? This is y test is nothing but the actual. Y pred is nothing but just now you have predicted. Actual and predicted you need to pass. Actual values and predicted values you need to pass here. Okay, now if you run you will get some value 3.155. Okay, this is the mean absolute error. What is the percentage error? You have got 0.16. Okay, 0.16 is the percentage error. Same way y test and y pred. Okay, mean square error. Sorry sir, I didn't run it now. 3.5, 0.17, and the mean square error you have got 23. Okay, LDL it is 20. Now you have got 23 because we have changed the data arrangements. So that's why you have got that error. Yesterday we have seen adjusted R square also. Okay, so we will see now how to use the adjusted. Sorry, how to calculate that particular adjusted R square in scikit-learn. Okay, so it will present in the metrics only from sklearn dot metrics import R2 score. Okay, you have imported it. Now R2 score, it will also accept the actual, nothing but the y test and the predicted 0.75, which is very nearer to the 1, very nearer to the 1. Okay, which means which means that the model is an average model. It's not the best model. So if you are having the values between 0 and 1, so it is some sort of average and it is very close to 1. So you can call it as a above average model. Okay, so like this you will be doing the predictions. Is it clear, guys? How we are doing and all? Okay, very simple. You are not doing anything. Just you need to remember the procedure and these functions you need to remember. Okay, these functions you need to just remember them. Train test split and applying the linear regression value and all. That's it. Then everything will works fine basically. Okay. Now For your practice, guys, you can take any sort of the data set. Okay, you can search in the internet, and create an account in the Kaggle. Okay, I think most of you people know the Kaggle website. Okay, Kaggle.com. So what they will do is, it's a very large AI and ML community. Okay, they will also host the competition, so you can also go with the competition once you get perfect in the concepts of all the AI and related stuff. Okay, ML related stuff. There are many. They will also give the huge prize money. Okay, see LLM prompt recovery, something. It's a competition. It's giving $2 lakh. Okay, so it's an open kind of thing. Google AI assistants for data task with Gemini. They are giving $50,000. $50,000 means it's a very, very, very high kind of thing. Okay. So all these are the competitions where you can participate. Okay, harmful brain activity classification. Okay, all these things you can just explore the all these are the competitions. Okay, previous competition, recently completed competitions. Okay, and see the data sets. Okay, data sets are their models, are their code discussion. If you want any in here, if you want to go beyond this one, you can explore the courses here. Okay, and you can explore whatever the thing is there. Okay, so for example, models is there. Okay, Gemini model by Google. Okay, lane detection, identification. You will get the code snippets as well here. Okay, for that particular what you call project or anything. Okay, so if you click on the code, you will be getting the work others what they have done. Okay, 9,000 plus movies data set. If you want the movies data set, this is the movies data set. Loan default prediction, sentiment analysis. Okay, next, the most important part is the data sets. What type of data sets you have? So it has a vast collection of the data sets, and there are many people out there. So PII detection is for the banking application. Okay, so how to use this particular Kaggle? Okay, you have everything here. For example, if you want to enhance more on the linear regression. Okay, so in this particular internship program, we can't cover entire machine learning. Okay, it's just a kind of like a crash course for you all people. If you want to enhance your skill sets in the machine learning even further, you can use this Kaggle platform basically. Okay, so linear. If you type the search linear regression like this, you will get many simple linear regression, multi-level linear regression. Okay, different people uses different approaches for doing the linear regression. We have done very traditional way. Okay, minimum linear regression is there, blending with the linear regression, medical insurance cost with linear regression. See this. Okay, so if you open that notebook, input output logs, all this will be there in the notebook. If you scroll down and see, he has took some data set. The data set has age of the beneficiary, gender, Okay. And what is the BMI, body to body mass index ratio, whether he is having the children or not, he's a smoker or not, and what is the region of in the US he's taking that region. Okay, just download the data set and see here. He just done. He's just verifying how many null values are there. There are no null values, and he's checking the distribution here. Distribute what is the distribution of charges. Okay, and then he's checking the distribution of. Sorry, he applied the log transformation for this, and he made the distribution to the normal distribution. Okay, see, this distribution is right skewed. So to make it closer to normal, we applied natural logarithmic log distribution. Okay, just log he has applied on top of all the values. So it has changed it to the normal distribution. Okay, in the same way he has done for which he has checked the outliers, whether there are any outliers or not, like that. Okay, all this you can thoroughly, he has also mentioned the points. You can go through these points and you can learn something. Okay, so different people you goes with the different assumptions and different way of applying the algorithm. It's not the thing that this is the only way of applying the algo. No. Okay, different people uses the different way of perspective of thinking and applying. They look the data set in different way. Okay, we need to go through all of, you can't go all of them and you can't apply everything, but you need to do the hit and trial while training the data. If that particular approach is not working fine, then again do some research and go with some other part. Okay, he's just checking the distributions here. This is another type of plot. He's for violin plot. Okay, so you need to go through all these things. So he's following the same thing. Okay, so as a holdout he has used, or else whatever the approach we have done, similarly you can do this. Okay, ridge regression, raster regression, these models also he has applied. Okay, just go through this. Just go through these kind of things. Okay, in your free time, I will share this one with your in the chat box here. Okay, you go through them some different data set or some different uh, model or basically, and you can understand how they have applied the linear regression on that particular data set, and how what are the parameter tuning they have done, what are the pre-processing steps they have done. See, another guy has performed a multiple linear regression. He has just explained about the model, the formula, what we have learned yesterday. Okay, that's the thing. There are many such kind of things. You can just explore the Kaggle website. Okay, so he has explained this another one, the bike sharing multiple linear regression. So this is the problem statement. He has clearly explained about the problem statement. What is the business goal of it? Okay, and just to go through all these things. Okay, he didn't check the uh, distribution, I guess, here in this. Okay, he might have followed the different principle, different aspects. Here he has checked the distribution. Here he has checked the distribution. Okay, so someone will follow like this, someone will follow like that. Just you need to explore, you need to learn, you need to note down all the process and the steps what others are following. Okay, but it takes a lot of time, guys, for learning entire machine learning. You can't even learn entire thing and you can be able to perfect in that machine learning or in the AI. See, in a if a programming language is a stagnant one, it's a fixed one, you are having some boundaries there. Okay, and you are having some limits there. Okay, so you will be enough of the topic, enough with the topics you are learning in the programming language. But in case of machine learning, it's not like that. It's a continuous learning process. Okay, so even if you get the job in the working and everywhere, you need to explore what are the different things are there, and then based on the problem statement you need to apply. So it's a continuous learning process, it won't stop there itself. Okay, so go through this Kaggle website and search it the internet and work on it. Okay, clear everyone? Okay, then we do one thing. We'll continue the class tomorrow. Tomorrow we will see the derivation part of the logistic regression from the linear regression. Okay, so it's a kind of like important one. You will be like, if you know the logistic regression, then everyone will ask the formula derivation in the interview. Okay, we will see the derivation part, how it will be done. Okay, guys, if you're not having any queries, you can drop off, guys.